My name is Mohammed Layiq Sediqi, the father of Holophase, Episode 5, Part 4. The living dimensions, how time, space, and motion each have their own cascades of change. My friend, welcome back. By now, you and I have already climbed a few big mountains together. In the early episodes, we asked a very simple but very dangerous question: what is real? Then we dared to question whether energy is truly the fundamental stuff of the universe, or whether it is just a very useful summary of something deeper. Then we met Phi, the hidden rhythm running through reality, and we introduced the idea of dimensional expression, the claim that what we call time, space, and motion are not three separate substances, but three different ways of reading that one underlying rhythm. In part 1 and part 2 of this episode, we did something delicate. We showed that time, space, and motion behave like three readouts of the same phase pattern, the same holophase. If you change the pattern of phi, you do not just change time, or just change space, or just change motion. You touch all three together. Now, in this part 4, we are going to push that idea one level deeper. Up to now, we talked about time as how quickly the rhythm ticks, space as how the rhythm varies from place to place, motion as how features of the rhythm slide through the world. That was already a big shift. But there is another layer that we have not fully opened yet. None of these dimensions is static. Each dimension has its own dynamics, its own living tower of rates of change stacked on top of one another. You already know this for ordinary motion. Even if you have never used the words, you feel it in your body. Position, velocity, acceleration, jerk, snap, and so on. The holophase twist is this: the same kind of nested hierarchy exists in the temporal dimension and in the spatial dimension as well. Time has layers of change. Space has layers of change. And all of those layers are just different directions in which the same underlying rhythm, phi, is changing. So in this part, we are going to start with what you already know, the dynamics of motion. Then extend that intuition to the flow of time as something that can itself change. Then extend it again to the shape of space, which can stretch, bend, ripple, and evolve. And finally, bring them together and show that all three hierarchies are really echoes of one deeper hierarchy inside phi. We are going to do this in very simple language with examples you can actually feel in your everyday life. And as always, this is not just poetry. Holophase only earns the right to be taken seriously if it can be wrong. So we will keep falsifiability at the center. We will ask, in plain words, what would the world have to look like for this living dimensions picture to fail? Let us begin. You want the familiar case, dynamics of motion. We start with the dimension your body already understands very well, motion. Imagine you are sitting in a car. At first, the car is parked. You are sitting still, maybe with your seatbelt on. Your position is fixed. You are here, not there. Then the driver gently presses the accelerator. The car starts rolling forward. Now you are not just somewhere, you are changing where you are. That change per unit time is what we call velocity. If the driver presses harder, you feel your back pressed into the seat. Your body leans. Now your velocity itself is changing. That change of velocity per unit time is what we call acceleration. Then imagine the driver is a little uneven. Sometimes they press the pedal, sometimes they release it, sometimes they tap it quickly. You feel a kind of jerkiness in your body, a tugging forward and back. The change of acceleration per unit time is called jerks. So, even in this simple car ride, you have already met a whole hierarchy. Position, where you are. Velocity, how fast your position is changing. Acceleration, how fast your velocity is changing. Jerk, how fast your acceleration is changing. And in principle, this ladder continues to even higher levels of change, though in daily life we rarely name them. You can picture this hierarchy like levels in a building. On the ground floor is position, just being somewhere. On the first floor is velocity, how quickly the ground floor is shifting. On the second floor is acceleration, how quickly the first floor is changing. On the third floor is jerk, how quickly the second floor is changing. Each level describes the change of the level beneath it. You feel all these levels in your body. When a car moves at a steady speed on a smooth road, you feel almost nothing. That is constant velocity. When the car speeds up smoothly, you feel yourself pushed gently back. That is acceleration. When the acceleration itself jumps, for example, when the driver suddenly brakes hard, you feel a sharp tug. That is jerk. Now, in Holophase, we take this familiar motion hierarchy and we say something bold. We say, this is not just a story about cars and roads. This is how reality itself expresses change along what we call the motion direction. If you imagine the world as made of patterns in phi, then the position of something is really where in space a certain phase pattern shows up. The velocity is how quickly that phase pattern shifts its location. The acceleration is how quickly the speed of that phase pattern changes. The jerk is how sharply that speed change itself turns. So even here, in motion alone, we are already looking at how quickly the rhythm is changing and how the change of change is evolving. Fine. That is motion. Now we take the radical step. What if time itself is not a rigid background, but something that can speed up, slow down, and change how it flows? And what if space itself is not a fixed stage, but a shape that can stretch, squeeze, bend, and send out ripples? That is where we go next. 2. Dynamics of time, when the flow itself has a flow. Most of us grow up with a very simple picture of time. There is one cosmic clock somewhere in the background. It ticks at a constant rate. Everything that happens in that time, like actors moving on a stage while a single drum beats behind the curtain. Holophase says that picture is too simple. The universe is more interesting than that. The key idea is this. The flow of time is not a fixed backdrop. It is how quickly phi is turning locally in your patch of the universe. Let's slow that down. Imagine a tiny rhythm maker at every point in space. It could be a little wave, a tiny pendulum, or an invisible ticking process. Its job is to keep track of how far the underlying rhythm has turned. Its ticking rate, how many beats per second, is the local tempo of reality. In one region, that tempo might be very fast. In another region, it might be slower. You can think of time in that region as how many beats of phi have passed. A simple way to feel this is to imagine a giant concert hall. In one corner, a drummer is playing fast. In another corner, a drummer is playing slow. The people standing near the fast drummer hear a dense, rapid beat. The people near the slow drummer hear a lazy, stretched out beat. If you asked each group to clap along and count 1 second according to their drummer, they would not agree. The fast corner would squeeze more events into their seconds than the slow corner. Holophase is saying the universe behaves like that. Where phi turns faster, local time flows quicker. More internal beats of reality fit into what some other region might call 1 second. Where phi turns slower, local time flows slower. Fewer internal beats fit into the same external reference. This is not just a metaphor. Physics has already given us very concrete hints of this. Think of clocks on Earth and clocks in orbit. Your phone's GPS would simply not work if we did not correct for the fact that time flows differently up in the satellites compared to down here on the ground. Clocks on fast-moving satellites and clocks close to massive bodies tick at different rates. From a holophase viewpoint, that is simply the rhythm of phi is evolving at slightly different speeds in those different regions. So already we see that time has dynamics. The flow of time can differ from place to place and from situation to situation. But just like motion, time does not stop at flow rate. It has its own hierarchy. At the simplest level, you can compare how much time has passed here versus there. That is like a temporal offset. Then you can ask, how fast is time flowing here right now? That is like the local time rate. Then you can ask, is the flow of time itself speeding up or slowing down here? That is a kind of temporal acceleration. Then you can ask, note, is that change smooth or does it come in jolts? That is a kind of temporal jerk. You already meet early versions of these ideas when you hear about an expanding universe, changing gravitational fields, or cosmological models where the rate of cosmic expansion changes over time. In all those situations buried under the technical language, there is a simple story. The way we measure durations is not frozen. The structure of time itself evolves. Holophase turns this into a clear statement. Time is a living flow. That flow has rates of change, and those rates of change are nothing but different levels at which phi's rhythm is changing in your region. Now, just to avoid confusion, let me add one more point. We all know the feeling that time flies when we are happy and drags when we are bored. That is psychological time, the time inside our experience. Holophase is talking about physical time, the time our best clocks measure. These two can influence each other, but they are not the same thing. Physical time in the holophase picture is still anchored to measurable rhythms, atomic transitions, light waves, oscillators. What changes is not our mood, but the actual tempo of phi in different regions. The reason this is not just poetic is that it can, in principle, be measured. You can set up networks of clocks, interferometers, and oscillators. You can move them into different gravitational fields, accelerate them, or place them at different heights. Then you can compare how their ticks diverge over months or years. Those patterns of divergence tell you about local time flow and the higher layers of its dynamics. If we ever discovered a region where all phase-based clocks agreed about their local environment but still predicted different, incompatible structures of time flow that could not be expressed as changes in phi, then the holophase story about time would be in trouble. That is how seriously we mean it when we say time is a dynamic readout of phi. 3. Dynamics of space. Geometry that breathes now. Let us talk about space. Many of us, especially as children, imagine space as a big invisible box, a three-dimensional grid that was always there waiting to be filled by stars and planets and us. In that picture, the grid itself never changes. Only the objects inside it move. Modern physics has already broken that picture. Relativity tells us that space can stretch, space can bend, space can ripple. Our telescopes and detectors tell us the universe is expanding. Galaxies are, on average, getting farther apart over time. Near massive objects like stars and black holes, space curves, light rays bend, straight lines are not straight anymore. Gravitational waves pass through space and literally stretch and squeeze distances in a rhythmic way. Holophase takes all of this and gives it a clear foundation. The shape of space is how phi varies from place to place. Earlier we said, if phi changes quickly as you move in some direction, that direction feels short in phase terms. Many cycles of the rhythm fit into a small physical distance. If phi changes slowly over a region, that region feels long in phase terms. You have to move a long way to see the rhythm go through a full cycle. That was the static picture, how the phase pattern is laid out at a single moment. Now we ask, how does that pattern itself evolve? How does space change over time? We can again think in levels. At the most basic level, you have spatial arrangement, how far apart things are, what their angles are. This is like the current photograph of geometry. Then you have spatial flow. Do distances grow or shrink? Are regions of space expanding or contracting? That is like the breathing of geometry. Then you have curvature evolution. Are the bends and warps in space themselves changing over time? Does the amount of warping grow, shrink, or move? Finally, you have ripples of curvature, waves of changing geometry that move through space, like the gravitational waves we now detect on Earth. A simple analogy helps. Imagine a large rubber sheet stretched tight on a table. You draw a neat grid of small squares on it, like graph paper. At first, the squares are all the same size, that is flat space. Now pull gently on the edges of the sheet. The squares stretch. Distances between points grow. The grid lines move apart. You have created expansion. Now, push your fist into the sheet from underneath. Near your fist, the squares distort. Distances change unevenly. Some lines bend. You have created curvature. Now start to move your fist up and down in a steady rhythm. Ripples travel outward across the sheet. As each ripple passes a given square, it stretches and shrinks rhythmically before returning to normal. That is like a gravitational wave. From a holophase point of view, all of this is encoded in how phi changes from one point on the sheet to another and how that pattern evolves in time. If phi's pattern is becoming smoother in a region, that corresponds to one kind of spatial evolution. If phi's pattern is becoming sharper or more tightly wound, that corresponds to another. If the way phi's pattern twists and curves is itself changing in time and sending out waves, that is a dynamic, living geometry. Another everyday picture is the expanding balloon. Take a balloon and draw small dots all over it with a marker. Each dot is a galaxy. Now start blowing up the balloon. As the balloon grows, every dot moves away from every other dot. There is no single preferred center on the surface. The whole surface is stretching. This is how cosmologists often picture the expansion of the universe. Holophase simply adds, the way the surface stretches is another way of saying how the phase pattern, phi, is being rearranged. Distances between phase features grow. The geometry is not a static stage, it is a breathing pattern. So, just as motion has its hierarchy and time has its hierarchy, space has its own living tower of dynamics. And again, these are not just metaphors. We measure them. We build detectors that can sense extremely tiny changes in distance as gravitational waves pass. We build telescopes that can see how galaxies move and how the large-scale structure of the universe grows. We run precision experiments that test how gravity behaves in small regions and how curvature shows up in physical measurements. Holophase says, all of these phenomena must be expressible as changes in the spatial structure of pi. If you ever find a geometric behavior, some pattern of stretching, bending, or rippling, that cannot be encoded in any consistent phase pattern, then the holophase picture, at least in that domain, is wrong. 4. One deep hierarchy, three-dimensional echoes. Now we can finally put all three together. We have three living towers: the motion hierarchy, position, velocity, acceleration, jerk, and so on. The time hierarchy, how much time has passed here versus there, how fast time is flowing right now, how that flow speeds up or slows down, how smoothly or abruptly that change happens. The space hierarchy, distances and angles, expansion and contraction and shear, evolution of curvature, ripples of geometry. At first glance, these might look like three separate pieces of mathematics or three separate sets of ideas. Holophase says something much tighter. They are three projections of the same deeper hierarchy inside phi. To help you feel this, imagine phi as a huge, multi-layered musical score. This score is not printed on a page. It is spread across the universe. It tells you at every point where you are in the rhythm and how that rhythm is changing. If you read the score along what we call the time direction, you see how fast each part of the universe is ticking. You see the hierarchy of time flow rates, accelerations of flow, and so on. If you read the score across space, you see how the rhythm twists and bends as you move. You see the hierarchy of distances, expansions, curvature changes, and waves in geometry. If you follow certain repeating patterns in the score, like particular motifs, phase features, or wave crests, and you track how they move and change, you see the hierarchy of motion, position, velocity, acceleration, jerk. From phi's own point of view, nothing mysterious is happening. You are always doing the same simple thing. You are asking, how is this rhythm changing here? And then, how is the change of the change evolving? You might be asking that along what we call time. You might be asking that across what we call space. You might be asking that along what we call a trajectory. But underneath, it is always one rhythm field, one holophase, expressing itself differently depending on how you look at it. That is what we mean by simultaneous dimensional expression. Time, space, and motion are not three independent universes. They are three different faces of one evolving phi. 5. Falsifiability. How could this living dimensions picture be wrong? Now we come back to the promise. This cannot just be a pretty story. If holophase is to be real physics and not just a philosophy of the universe, there must be clear ways in which this picture could fail. So let us keep this practical and simple. Test family 1. Networks of clocks and the flow of time. If time's flow is just the local ticking of phi, then clocks built from different kinds of physical rhythms, atoms, crystals, mechanical oscillators, light-based interferometers, should all be describable as different ways of reading that same phi. You can imagine building a web of clocks, some on Earth's surface, some on satellites, some near stronger gravitational fields, some in fast-moving rockets. You then compare how their readings drift apart over long periods. Holophase predicts you can always find a description where these differences come from one underlying phase field and how it evolves locally. If you need to introduce several independent times that cannot be reconciled as different views of one phi, the model begins to crack. A direct failure would look like this. You find two kinds of clocks that both measure phase in some fundamental way, and no matter how you try, you cannot explain their disagreements with a single phi pattern. They behave as if they are responding to two different ultimate rhythms. That would challenge the Holophase claim that there is one underlying phase field behind all physical time. Test family 2, spatial dynamics and phase geometry. If space is the spatial structure of phi, then all observed stretching, bending, and rippling of distances must be expressible as changes in that structure. You look at gravitational wave data, cosmological data on expansion, precision measurements of local gravity and curvature. If you can describe these with one phase geometry story, Holophase survives that test. If you find a stable, well-tested phenomenon where geometry behaves in a way that no phase configuration can reproduce, then Holophase is wounded. Test family 3, linking motion, time, and space together. The deepest test is not about any one dimension. It is about their relationship. When motion, time flow, and spatial structure all change together, do they always behave as if they are three readings of one hidden process? Imagine an experiment where you track moving patterns, compare multiple kinds of clocks, monitor distances, angles, and possible ripples in geometry. Holophase says there must exist a single evolving phi story that explains all three data sets at once. You might need to do some work, but in principle it must be possible. If you find an experiment where the motion data fit one phi-like story, but the time data stubbornly refuse to fit, or the spatial data demand a completely different underlying structure, then the unified dimensional expression fails in that domain. In that case, you would have shown that at least part of reality cannot be described as one rhythm with three faces. You would have cut the holophase picture apart, and that is exactly the kind of risk a serious model must be willing to take. 6. Why any of this matters. You might be thinking, this is all very interesting and maybe even beautiful, but why does it matter that time, space, and motion each have their own cascades of change tied to one rhythm? Here is why. If time, space, and motion were fundamentally separate things, then the tight relationships we see between them would be mysterious. You would need three different basic ingredients in your ontology. You would then need extra rules to explain why changing motion affects time, why gravity affects both time and space, why extreme speeds and strong gravitational fields tie all three together. The fact that they lock together so precisely in relativity and in our measurements would feel like a miracle that we simply accept. But if time, space, and motion are three faces of one rhythm, none of that is mysterious. Of course, changing motion affects time and space. You have simply tilted how you are reading phi. Of course, gravity affects both time rates and spatial geometry. Gravity is just one way the phase pattern curves. Of course, you cannot change the speed of light without messing with how time and space are measured. All of them are part of one deeper structure. Seeing dimensions as dynamic readouts of phi gives us a more powerful language to talk about the evolution of the universe. Instead of saying, objects move in a static space-time box, we can say, a single living rhythm unfolds, and we experience its evolution as changes in how time flows, changes in how space is shaped, and changes in how motion patterns move. This matters even more for what comes later in the holophase roadmap: the emergence of forces, the behavior of waves and particles, the birth of thermodynamics and information, the appearance of biological systems, minds, and conscious experience. All of these higher-level stories depend crucially on how dimensions behave, not just on the fact that dimensions exist. Holophase makes a sharp claim: if you can describe a phenomenon in terms of time, space, and motion and how they change, then at a deeper level, you should be able to describe it as phi doing something and its derivatives doing something. If that ever turns out to be impossible for some part of reality, if there is a phenomenon whose dimensional behavior stubbornly refuses to be captured as the dynamics of a single phase field, then holophase will have to be revised or abandoned. And that is exactly the way it should be. A theory that cannot, even in principle, be broken by evidence is not a theory. It is a story that cannot lose. Holophase wants to be something else, a story that can be tested, stressed, and, if necessary, killed by reality itself. Before we close, let me give you three small stories that tie everything together even more tightly. Story 1. The Two Towers. Imagine a city with two very tall towers. In Tower A, at the ground floor, a scientist places a very precise clock. In Tower B, at the top floor, another scientist places an identical clock. They synchronize the clocks and let them run for a year. At the end of the year, they bring the clocks together and compare them. The clocks do not agree perfectly. Physics tells us that time at different heights in a gravitational field flows at slightly different rates. Clocks closer to the center of the Earth tick a little more slowly than clocks higher up. The Holophase way of saying the same thing is the rhythm of P is a little slower deeper in the gravitational well and a little faster higher up. The clocks are not disagreeing about some mystical thing called time. They are faithfully reporting how quickly phi turned in their local regions. Time here is a dimensional echo of the underlying phase. Story 2. The stretching balloon. Take a balloon and draw small dots all over it with a marker. Each dot is a galaxy. Now start inflating the balloon. As the balloon grows, every dot moves away from every other dot. There is no single center on the surface of the balloon. It is the whole surface that is stretching. That is a simple picture of cosmic expansion. From the holophase point of view, the stretching corresponds to changes in how phi is laid out across space. The distances between phase features grow. The geometry is not a fixed backdrop. It is a living pattern that can breathe. Story 3. The moving pattern on the stadium. Imagine a stadium full of people holding small lights. Each person is standing still. The seats do not move. The stadium is not rotating. But now they start flashing their lights in a coordinated way so that a bright wave travels around the stadium. You see a ring of light racing along the rows. If you did not know better, you might think something is literally racing around the stadium. But what is moving is a pattern, not the people. In ordinary physics, we already use this idea to understand sound waves, water waves, and light waves. Holophase takes this pattern idea and says the position of that wave is one way of reading phi. The speed of that wave is another way of reading phi. The way that wave speeds up, slows down, or breaks apart is yet another way of reading phi. Time, space, and motion are three different ways of watching that stadium pattern play out. If we changed the rhythm that each person followed, we would change what we see as time, how often the pattern repeats, space, how tightly the pattern is packed around the stadium, and motion, how fast the bright ring seems to race. These three stories, the two towers, the stretching balloon, and the stadium wave, all point to the same simple lesson. When you look carefully at the best experiments we have, the things we call time, space, and motion are always tied to some underlying rhythm and its changes. Holophase takes that lesson seriously and pushes it to its logical conclusion. There is one rhythm field, phi. Time, space, and motion are three ways of measuring how that rhythm changes. Their hierarchies of change, velocity and acceleration, flow and flow of flow, expansion and ripples, are three different shadows of one deeper hierarchy of phase derivatives. For now, I invite you to carry one simple picture with you as we move forward. The universe is not resting on a rigid, invisible grid of space and time. It is more like a living rhythm. What we call time, what we call space, and what we call motion are three different ways that our instruments and our own minds have learned to read that rhythm. In the next part of this episode, we will take this living dimensional picture and start bending it toward the next big step. We will explore how laws of motion can be seen as rules about how phi is allowed to change. We will begin to see forces not as invisible pushes and pulls, but as patterns in how the rhythm accelerates and curves. And we will see how energy reappears not as the basic substance of reality, but as a very clever summary of what the hidden rhythm is doing across all three dimensions at once. For now, thank you for walking with me through these living dimensions. You are not just listening, you are training your intuition to see the world in a new way. You are learning to look at any situation and quietly ask, what is time really doing here? What is space really doing here? What is motion really doing here? And underneath all of that, what might phi be doing underneath the surface? That question, more than anything else, is the heart of the holophase journey.